We talked about intercepts of quadratic functions, intercepts of linear functions, intercepts of polynomial functions. Well, now let's do intercepts of rational functions. So we need the intercepts. Here we have x and y. So remember the x-intercepts. Those are going to be when y is equal to 0. And the y-intercept is going to be when x equals 0. That's how we find vertical and horizontal intercepts. The intercepts are just where we cross an axis. The vertical intercept, cross the vertical axis. That's when x is 0, when the input is 0. So let's find what each of these have to be. The x-intercept is when y is equal to 0. This is our y. Okay. Right here is our y. So when that is equal to 0, what do we get? We get something that looks a little alarming. A little alarming. That doesn't look easy to solve. But it's actually much easier than you think. Okay, there's good news here. It's not as bad as it looks. So to solve equations with fractions, we want to get rid of the fractions. So the way that we get rid of the fractions is we multiply both sides of the equation by the denominator. Just like, right, if we had 1/5 x equals 2, what would we do? We multiplied both sides by the denominator. And that cancels the fraction, and we get x is equal to 10. What we're doing here is nothing different. And look what happens when we multiply both sides of the equation by this denominator. X minus 1, x plus 2, I don't have room. X minus 5. Look what happens to that left-hand side, right? 0 times all this stuff, that's just 0. And the right-hand side, well, we have an x minus 1 on the top, right? We can think about it like this. X minus, we have the same factor. The same factors are going to cancel. So our right-hand side turns out to something really nice. Now, this is only true under certain conditions. This is only true if x isn't 1 or -2 or 5. Why can't x be any of these? Why is this only true if x is none of these numbers? Because if x is equal to one of these numbers, then what are we multiplying both sides of the equation by? If x is equal to 1, we're multiplying both sides of this equation by 0, which is not the best problem-solving technique, right? Right? Say you're trying to solve an equation and you say, well, let's multiply both sides by 0. Great. Make it a little sad face. We never want to multiply or divide both sides of an equation by 0. That's silly. So, not useful. So we have to make sure that, okay, if we're multiplying both sides of this equation, let's make sure we're not multiplying both sides by 0. But now we're almost done, right? When is this true? A factored polynomial is equal to 0 if any individual piece is equal to 0. This is true when x is equal to 2 and when x is equal to -3. Great. So let's just, make sure that none of these match. Right? If these match, we throw it away. Because this is only true if we're not those numbers. If we did get the same numbers, we'd have to toss it. So our y equals 0, our x-intercept is when x is equal to 2 and y is 0, when x is -3 and y is 0. The other one's going to be easier. The y-intercept is easier. The y-intercept is when x is equal to 0. That's just plugging in 0 into our function. 0 minus 2, 0 plus 3, 0 minus 1, 0 plus 2, 0 minus 5. Type that into a calculator. You'll get -6 over 10, 3/5, I believe. So the y-intercept is when x is equal to 0 and y is 3/5. Let's check our answers. Okay. X minus 2, x plus 3. Divided by x minus 1, x plus 2, x minus 5. Do these have the right intercepts? Is that negative 3/5? Yeah, it is. Negative 6/10. X-intercept right there. X-intercept right there. Were there any more? No. It's really close to 0. It never crosses 0 again. Those are the only ones where it crosses 0. Those are all our intercepts. We did it right. Nice. Great. Now is your opportunity to try it. Try to pause the video and see if we got the same thing. And also one comment about this red thing right here. If they match, that would be like if we had something like this. If we have something like this, there's a hole there. And that's why it wouldn't be an intercept anymore. It's probably not going to happen in this class, but it could happen theoretically. So if there's a hole, it can't be an intercept there. Anyway, here we go. So it turns out, all right, well, let's not make that comment now. So we need a horizontal intercept for the y. Horizontal intercept is going to be our t-intercept. However you want to write it. That's when the output is 0. And the vertical intercept, you'd call it your g-intercept, your y-intercept, whatever. That's when your input is 0. So the output is 0 when this is the case. If you want to be lazy and not write out all the multiplication, you can. It's going to be true when 0 is t minus 3 times t plus 3. And again, this is only true when t is not equal to -1 or -2. Probably won't be a problem in this class. So our horizontal intercepts are when t is +3 or -3. Similarly, our vertical intercept is when t is equal to 0. When we plug in 0, what do we get? 0 minus 3, 0 plus 3, 0 plus 1, 0 plus 2. -9 over 2. -9 halves or -4.5. However you want to phrase it. So our intercepts are when t is -3 and the output 0. When t is +3 and the output 0. When the input is 0 and the output is -4.5. And we can check our answer here. G of t equals t minus 3, t plus 3, divided by t plus 1, t plus 2. Are our intercepts right? Oh yeah. You bet our intercepts are right. Nice. Those are the only intercepts. We did good. That's it for intercepts. Let me know if you have any questions.